Okay, we are going to start the seventh section of chapter 4, which is solving nonlinear systems of equations with two learning targets, one of which we're going to focus on more. The first is that you can solve real world problems, and then lastly, that you can solve systems of nonlinear equations algebraically. Now, you have to remember we have solved systems of nonlinear equations in the past. And when doing so, we've had like one linear equation and one quadratic. And if we're having no solutions, that means that those graphs just don't intersect at all. Okay, so we're going to find in our section today, we'll find out a little bit more about that. Okay, we can also have two quadratics. So again, if there's no solutions to them, they're just kind of passing by each other some way or somehow. They're just never going to intersect. Okay, one, which means they're just going to go ahead and only have one solution. That means they're crossing one time. So that would be an example of maybe a parabola like this, and a line just coming right on by it, just barely touching it one time. And then, with two parabolas, this could look a number of different ways. Maybe we have like a wider parabola here and they share a vertex, and this one's opening and is very narrow, or something along those lines. It could be opening downward, for example. And then lastly, we can have two solutions. So that would be a parabola opening up or down and a line cutting through it somehow, some way, crossing at two spots. Parabola is kind of the same concept. It's just going to intersect twice. So maybe we have a parabola opening downward like this, and then a parabola opening down upward like that, and then they just kind of intersect each other here. Okay, so we need to understand that this is graphically what's happening. So what are the different ways that we've solved systems? Because we started out an entire chapter at the beginning of the year solving systems. Then we spent a little bit of time solving systems of linear and nonlinear equations in chapter 3. And if you recall, in chapter 3, we did the graphing method. Okay, this was done again in chapter 3. Okay, so this is not going to be a method that we'll use today. But, some highlights of that, we would see where two lines or curves intersect. That's a general concept. We're trying to find where the x value and the y value is true for both equations. And simply put, that's just where the graphs intersect each other. So that's visually what's happening. Okay. We also use substitution. Okay. This was way back in chapter 1. Okay. And what was this? This was isolating a variable. And then substituting it back into the other equation. All right. And then lastly, there was the elimination method. Again, this was done back in chapter 1. And in chapter 1, this is one where we created opposites in a variable. And once we created opposites, if you recall, we could add them together because then the opposite variables would cancel each other out, leaving us with an equation that allows us to solve with one variable, which those are the easiest to do. So add the two equations to cancel out a variable. So those were our different methods of solving systems. And the thing that's kind of wonderful about math is that these same methods are going to hold true. It's just about the execution after we do the substitution, elimination, or graphing is different when you have equations of higher degrees. So let's go ahead and just dive into some of these problems. We're going to start out with what looks like to be the substitution method. Okay, when I'm solving the substitution method, our concept is that we isolate a variable, and then once we know what that variable is, we plug it into the other equation. When do you want to use this? You want to use this when either a variable is isolated already, or a variable can easily be isolated, typically one step, like just subtracting a value or adding a value. So here, as I look at number 1 here, I see that both are set equal to y, so that means I can take what y is equal to. Okay, I can take what y is equal to, and I can plug it into the other equation. I'm going to plug it in right here. You've seen this before. So that means instead of y, I'm going to write 2x plus 5 is equal to x squared plus 3x minus 1. So now that I have this equation, we have to think about how we're going to solve this, because in our first chapter, we often said, hey, just get the x by itself and figure out what it's equal to. It's a little more complicated than that when we come to these problems. So what do we have to do? How do we solve equations with a higher exponent, specifically an exponent of 2? Well, we set it equal to 0, we factor, and then we set those factors equal to 0. So that's what we're going to do today. So we need to set equal to 0. So we're going to subtract 2x. And then I'm actually going to subtract 5 also in one big swoop here. Plus x minus 6. Okay, and so then now I'm looking at this, and I have 0 is equal to x squared plus x minus 6. This is just a problem that we solved in section 4.1. We have a 3-term, we have a trinomial, and our a value is 1. That means we're looking for numbers that are going to multiply to -6 and add to +1. Okay, so again, if you don't know what those combinations are, you need to start listing the combinations that multiply to -6 on the side. 6 and 1. Well, we know 6 and 1. There's no way they can get to -6, but there's no way they're getting to +1. Our next combination would be 3 and 2. So we know that 3 and 2 is going to multiply. Well, looks like my screen may have froze here. All right, here we go. So we know that there's no way 6 and 1 are going to add to +1, but when I get to 3 and 2, there's a possibility that if one's positive and one's negative, I can add that to 1. So what is that combination? It looks like it's going to be x plus 3 and then x minus 2. Okay, 3 times -2 is -6. 3 plus -2 is +1. So then what do I do here? I set each factor equal to 0. All right. And then I can solve each of those factors. All right, so those are just the x values. This is important because if I just have x values, that doesn't tell me where these two graphs are going to cross, because that only gives me the x values. We need the y values that correlate to it. So knowing that, what we need to do is we need to go ahead and plug these values back in to find y. Okay, so let's go ahead and do that. So we would say y is equal to 2 times -3. Then we're going to add 5, okay? So that means y is equal to, so 2 times -3 plus 5 is -1. Okay, so our first solution is ordered pair -3, -1. And then we have a second pair, okay? This is going to be y equals 2 times 2. plus 5. Well, 2 times 2 is 4. 4 plus 5 is 9. So we're going to have a parabola, and then we're going to have a straight line, and they're going to cross at the ordered pairs. -3, -1, and 2, 9, meaning we have 2 solutions. Okay. And that's just the substitution method right there. Okay, let's move on to number 2. Okay, so when I'm looking at number 2, kind of the process is the same. I already see my variables are isolated, so I'm going to take what it's equal to and substitute it into the other equation. So I have the opposite of x minus 7.5 is equal to 2x squared plus 7x minus 4. Okay, and then I can go ahead and set this equal to 0. So I'm going to go ahead by adding x and adding 7.5. So then I'm going to get 0 is equal to 2x squared plus 8x, negative 4 plus 7.5, negative is 3.5, so plus 3.5. Okay. Now, as I look at this problem, this one seems as though it's quite confusing because we have yet to have a single problem that we factored that has a decimal. And that's because those are tough to think about the combinations, ultimately is what that is. So we need to alter this problem so we don't have to use a decimal. For example, 3.5, I just want to multiply that by a number so that it becomes a whole number. So it's a half, 3.5. So I'm just going to take everything and multiply it by 2. So 2 times 0 is 0. 2 times x squared times 2 is 4x squared. 8x times 2 is 16x. 3.5 times 2 is 7. Okay, so here I have 3 terms, and my a value is 1, meaning I have to use the Xbox method. Okay, so we're going to go b value here, which is 16, and a times c, so 4 times 7, which is 28. Then I'm looking for the combination of numbers that add to 16 and multiply to 28. That's 14 and 2. So then I can go ahead and set up a box here. 4x squared, and then 14x, and then 2x, and then 7. Okay, and then I can start taking my greatest common factors out. Greatest common factor between 2x and 7 is 1. Greatest common factor between 4x squared and 14x is 2x. Greatest common factor between 2x and 4x squared is 2x. Greatest common factor between 14x and 7 is 7. So this whole thing is going to factor into 2x plus 1 times 2x plus 7. Okay, and then I can set those equal to 0, each individual one. So 2x plus 1 is equal to 0, and 2x plus 7 is equal to 0. Okay, to find the x values, I'm going to have to subtract 1 here, so I get 2x is equal to negative 1. And then lastly, I'm going to have to divide by 2 to get x is equal to negative 1/2. Here, I would have to subtract by 7 to get 2x is equal to negative 7, and then divide by 2 to get x is equal to negative 7/2. Okay, and then I'm going to have to go ahead and just plug this in. Okay, I'm dealing with halves here, so I can probably use the decimal approximation. Now, that being said, when there is, how do I say this? When there's fractions that are like a third, those often don't add very nice. So we're going to let the calculator do all the heavy lifting here. So I'm going to show you how to do that as well. So the first one I'm going to do is when x is negative 1/2. And then subtract 7.5. So I'm just going to go ahead and plug this expression into my calculator. So I got the opposite of negative 1/2. Okay, and then I'm minusing 7.5. And I get negative 7. No, I don't even have to simplify that as a fraction because it's already negative 7. Okay, so my first ordered pair is negative 1/2, comma, negative 7. My second ordered pair is going to be negative 7/2, which I can do right here. And then I'm going to minus 7.5. Okay, same idea, so I'm going to go the opposite of negative 7/2, and then I'm going to take away 7.5 and get negative 4. Okay, so just go ahead and type it into your calculator. You've seen me do this before. If you get a decimal, you can go ahead and hit math, and then the very first option is frac, which stands for fraction. It will simplify your fraction for you, so we don't have to worry about that. All right. Okay, so that's how you do the substitution method. In general, it's pretty consistent with all the work we've done really this entire semester. I really like this section because it really truly just builds off of things that we've already done in the past. Okay. So now let's try A. I'm going to let you all try A on your own, and when you're done, check in with me. So go ahead, pause that video now, and then check it with me when you are done, which I'm assuming is right now. So here, assuming that you're here to check to see how you did, I'm going to take what y is equal to and replace it in the other equation. So I'm going to get x squared plus x plus 1 is equal to negative x plus 4, or the opposite of x plus 4. Then I want to have this set equal to 0, so I'm going to accomplish that by adding x and subtracting 4. So now I get x squared plus 2x minus 3 is equal to 0. I have 3 terms and my a value is 1, so I'm looking for numbers that multiply to negative 3 but add to 2. So multiply to negative 3 and add to 2. The only combination there is 3 and 1, so 3 has to be positive in order for me to add to a positive 2. So this is going to be x plus 3 times x minus 1 is equal to 0, which means x plus 3 is equal to 0, and x minus 1 is equal to 0, which means my two x values are negative 3 and positive 1. Okay, and then we can go ahead and plug those in to whatever equation. I'm typically using these ones, the linear ones, because they're the easiest to deal with. So let's go ahead and do that. So y is equal to the opposite of negative 3 plus 4. So that means y is equal to the opposite of negative 3 is positive 3. Positive 3 plus 4 is 7. So our first solution is negative 3, positive 7. And then our second solution, let's take the opposite of positive 1 and then add 4. So the opposite of positive 1 is negative 1. Negative 1 and 4 is 3. So my second solution is negative, or 1, positive 3. Okay. And that is letter A. Okay. Letter B. Again, concepts are all the same here. So here I'm going to take what y is equal to and replace it. So I get negative 2x minus 4 is equal to 3x squared minus 22x plus 24. And then I'm going to set equal to 0. Okay, so this one definitely has 3 terms here, and the a value is not 1. That means I have to use the Xbox method. So I'm looking for numbers that are going to add to negative 20, but multiply to whatever 3 times 28 is, 84. Okay. So for myself, I'm thinking to myself currently, I have absolutely no idea what adds to negative 20 but multiplies to negative 84. So I'm just going to go ahead and bust this thing out and start checking combinations. Well, I already know 84 and 1 is going to be a combination, but I know that's not getting me to negative 20. So then I'll try 2. So 42 and 20, I mean, I'm definitively closer, but again, 42 and 2 are not going to get me to 20. 28 and 3 got me very close. So that would get me to 25 or 31. Again, that's not going to be my combination. So then I'm going to go 84 and 4, 21. So that will not do it. So I know 5 is not going to work. So I'm just going to jump to 6. 6 and 14. That can get me to 20. It could also get me to 8. So this one is my combination. So here, 16 and 4 are my factors. Or 14, what did I said 16 and 4? I meant 14 and 6 is what I meant to say. Okay, I know they both have to be negative because I'm multiplying to a positive and adding to a negative. Okay, so now I can set up my box here. And 28. Okay. Now I have corner negatives. I have 2 negatives in each corner, so that means I'm going to be pulling negatives out here and here. Now I just don't have to think about negatives anymore. I just already know what they are. So 28 and 14x. So 28 and 14x, they're going to have a common factor of 14. So that is what I'm going to pull out there. And then 3x squared and negative 6x, that's going to have a common factor of 3x. 3x squared and negative 14 are going to have a common factor of x, and negative 6 and 28 is going to have a common factor of 2. So now I have 0 is equal to x minus 2 times 3x minus 14. Okay, which means that x minus 2 is equal to 0. So that means x is equal to 2. And then lastly, x minus 14 is equal to 0, which means 3x is equal to positive 14, which means x is equal to 14 thirds. Okay, this is going to be a great example for everybody here that you're just not going to be able to use a decimal. 14 over 3 is going to be 4 2/3, 4.6 repeated. So to get an exact answer, I want a fractional representation. So let's go ahead and we can plug these values in to get the ordered pairs for where this line crosses this parabola. So I'm going to get y is equal to negative 2 times 2. And then I'm going to minus 4 from that. So negative 2 times 2 is negative 8, or negative 4. Negative 4 minus 4 is negative 8. Let's jump in the gun there. So my first ordered pair is 2 comma negative 8. My second ordered pair is going to come from this 14 thirds. So that is going to be y equals negative 2 times 14 thirds minus 4, which means y is equal to, and this one here, I mean, even for myself, this is what I personally would do, is I would probably just throw it in the calculator. Not that I'm incapable of putting it or doing it by hand. I am, and we all are, but this is just the easiest, and our focus is not on adding and subtracting fractions for this lesson. It's about finding where these two, this curve and this line cross algebraically. So here what I'm going to do is I am going to multiply 2 times 14 thirds, and then I'm going to subtract 4. And as you can see, it does give me a weird decimal. I want the fraction equivalency to that, so you can go ahead and hit math, and then the first option, frac, will convert that into negative 40 thirds. So the other one is going to cross at 14 over 3, comma, negative 40 over 3. Okay, and this would be the expectation if you're having decimals. If they're not terminating, I need them as a fraction. That is going to be expected out of everybody. These are non-terminating decimals, so if you gave me negative 0.5, I would accept that, or negative 3.5, I would accept that because those are terminating decimals. These ones here, I want the exact answers, so fractions only. Okay, although some of these problems here can easily be solved using the substitution method, I also want to go ahead and give you tools that you can use to use the elimination method, because there's going to be situations where you might want them to use the elimination method. Okay, so if you recall, we want the elimination method to have variables that are opposites, and then we can add the equations together. So for example, when I'm looking at this here, my x squareds are already opposites, but there's no way I'm going to be able to make my x squareds and my bx terms opposites at the same time. So we want to try to make opposites in the y's here. One is positive y, the other's 1 positive y. So I'm going to take this top one and I'm going to multiply by -1. Okay, so then I'm going to get negative y is equal to x squared minus 10x plus 18. So now when I'm looking at the two equations here, I have opposites. So y plus negative y is going to be 0. They cancel out. X squared plus x squared is going to be 2x squared. Negative 4x plus negative 10x is negative 14x. And then negative 6 plus 18 is going to be positive 12. Okay, the next thing you want to do, just like any problem here, is I'm noticing I have a greatest common factor. All of these numbers are divisible by 2, so I'm going to divide everything by 2. 0 is equal to x squared minus 7x plus 6. I have 3 terms, and I know that they all are, and that my a value is 1, so I'm looking for numbers that multiply to 6 and add to negative 7. So I'm going to get 0 is equal to x minus 6 times x minus 1, which means x minus 6 is going to equal 0, or x minus 1 is going to equal 0, which means x equals 6, and x equals 1. Okay, next we have to, just like the previous one, we have to go ahead and solve for y. We have to figure out not only the x coordinate where these curves are going to cross, but we're going to find the y coordinate as well. So I need to just plug it into either equation. I'm going to use the bottom equation. It seems like it's easier with this less negative here. So again, we can just go ahead and plug in 6 into the equation. So y equals 6 squared minus 4 times 6. Okay, and then minus 1. So that means y is equal to, and we're just going to throw this in the calculator. 6 squared minus 4 times 6 minus 1, 5. So our first ordered pair here is ordered pair 6, 5. And then the other one, same thing, we just replace it with 1. All right, and I know I'm kind of picking up the speed here a little bit, but I know we don't like the videos longer than they have to be. So then here I'm going to do the same thing. 1 squared minus 4 times 1 minus 1, which is negative 4. Okay. Number 4. Number 4, same concept here. I want to multiply each of these. I would need to multiply an equation here to create opposites. So if and realistically for all these problems, they're going to be the y variable. So if I want to do this to the y variable, I'm going to go ahead and do this to the bottom one here. So I get the opposite of y is equal to 0.5x squared minus 4x minus 12. And okay, and so then these are going to cancel out to 0. This is going to go to 1.5x squared. That's going to be minus 21x, and that is 60. Okay, and so then here, now I have a 1.5. Okay, so it looks like we're going to have to scale this back up to get this to a whole number, just like we kind of saw in the other problems here. So this one I'm going to need to multiply by 2 to get 3x squared minus 42x plus 120. Okay, and so this ends up being convenient here because they're all divisible by 3 now. Okay, so even though we scaled up, that doesn't mean we can't scale back down, which this is a great example. What does that really mean? That means that all of these numbers are going to end up being divisible by 1.5 exactly, which is all fine here. So we're going to get x squared minus 42 divided by 3. I'm going to go ahead and check that just because I don't have that off the top of my head. 14. And then plus 120 divided by 3 should be 40. Okay. So this one we ended up having to do a little bit of work. And really why this ended up happening is this is 3 halves. 1.5 is the same as 3 halves. So we multiplied by 2 to undo that bottom 2, and then divided by 3 to undo the 3. No worries. So then here we can factor. We're looking for numbers that add a negative 14, but multiply to 40. That's going to be negative 10 and negative 4. And so then that means 0 is equal to x minus 10, and x minus 4 is equal to 0. So that means x is equal to 10, and x is also equal to 4. Okay, and then we can plug this in. Again, I'm not going to plug it into the more complex equation. I'm going to do it to the slightly simpler one. So I'm going to get y is equal to 10x, or 10 squared, minus 17 times 10, plus 72, which is 2. And then I'm going to do the exact same thing with 4. So 4 squared minus 17 times 4 plus 72. So that is 20. Okay. So that means our parabolas intersect at 10, 2, as well as at 4, 20. Okay. All right, so we've gone through quite a few of these examples. Okay, if you feel like you need the practice, I would suggest going ahead and going through C and D on your own. Pause the video, check it as we normally do. But if you're feeling confident about this, feel free just to move on to examples 5 and 6, and you can always come back to these if you need some more instruction. But otherwise, for those who feel like they need to try some of these problems on their own and are checking it with me, I'm going to do that right now. So I'm going to multiply this bottom one by negative 1. To get the opposite of y is equal to 0.5x squared minus 10x minus 18. To create opposites in my y's, as you can see I have here. Okay, and then now I can add them now that I have opposites. So that means y minus y, that's 0. This is 1.5x squared. This is minus 9x, negative 18, and 42. Negative 60. Okay, I kind of learned my lesson here on the previous one, that sometimes they are divisible by 1.5, and I'm kind of seeing these are all multiples of 3. Since these are multiples of 3, I have a hunch that they're all also multiples of 1.5. So let's go ahead and check. 9 divided by 1.5 is 6, and negative 60 divided by 1.5 is negative 40. So here I'm going to get x squared minus 6x minus 40. Okay. All right, so that one ended up being just like this. You should have got the same thing here if you multiplied by 2 first and then realized they're probably all divisible by 3. Almost the exact same type of situation. So now we just have to factor this. So I'm looking for numbers that multiply to 40 and add to negative 6. Luckily, as I was stalling here a moment, I realized it's going to be x minus 10 and x plus 4. And again, if you don't know what that is off the top of your head, feel free to start listing them out. That's exactly what I would do if I didn't come to the realization of what it is. So then that means x minus 10 is 0, or x plus 4 is 0. That means x is equal to 10, and x is equal to negative 4. Okay, now we just have to plug those in. I'm going to plug it into the top one. So y is equal to, here, 10 squared plus 10 minus 42. That means y is equal to, so 10 squared plus 10 minus 42 is 68. So this is going to intersect at the ordered pair 10, 68. Okay, and then the other one here, that means y is equal to, and I have a negative x value here, so that means I'm going to have to throw it in parentheses, especially when I'm squaring. And a lot of you, I know, often miss that. It's quite important because you will get the wrong answer if you do not do it that way. Okay, so here we're going to go negative 4 squared plus negative 4 minus 42. To get negative 30. All right, and so here we get negative 4 comma negative 30. Okay, and this is a very good example here because this is a prime example of why the graphing method can often fail us, because we would need a huge graph or need to be crazy accurate to be able to make this happen. Okay, letter D, same thing. I'm going to multiply the top one by negative 1. This one may not be as obvious which one you need to do that to. But if you think about it, we always want the x or the ax squared term to be positive. And so since I want my ax squared term to be positive, if I make this by negative 1, then I'm going to end up with a negative 1x squared, as opposed to if I make this negative, I'm going to end up with a positive 1x squared, which you're going to see right now. 3x squared plus negative 2x is just x squared. Negative 7x, and negative positive 6. Okay, and so that means 0 is equal to x minus 6 times x minus 1. We've almost had one just like this earlier, I feel like. Yes, this one up here. All right, so that means x minus 6 is 0, and x minus 1 is 0. And that means x is 6. And this means x is 1. Now we just have to find the y values. All right, I'm going to plug it in the top one. Looks like I'm overlapping just a bit, which is okay. Okay, so this one here, we're going to go 2 times 6 squared minus 15 times 6 plus 18. 0. Okay, very nice. So our first intersection point is 6, 0. Then we're going to have to do the same thing. I got to kind of shift it over here, though. Alrighty. So y is equal to, again, I'm going to do the same thing. I'm just going to type this back in again and just replace those 6's with 1's and get 5. So this intersects 2 spots at x is 1, y is 5. Okay. All right. Now for our last bit of these problems. Okay, so these are problems where, as you can see, my work is probably not going to factor. So that we have a couple different options that we can do. And my guess is most of you all are going to want to do one specific method. So that's the method I'm going to choose. So here, I can go ahead. I can use the substitution or elimination method. It really, honestly, doesn't matter. I personally prefer the substitution method, so that's what I'm going to use. So here, now I know that 3x minus 10 is going to equal x squared plus 4x minus 6. Then I'm going to have to subtract 3x and add 10. So now I'm going to get 0 is equal to x squared minus, or plus x plus 4. So here we're looking at this problem. This is the issue that is going to happen on occasion for you. Okay, so I get x squared plus x plus 4 is equal to 0. I need to factor this. Okay, so as I'm looking at this, I have 3 terms in my a values 1. I'd be looking for numbers that multiply to 4 but add to 1. It's not going to take you a whole lot of time because there's only 2 combinations. 4 and 1 add to 5, or it can get you to 5 or 3, or negative 5 or negative 3. So that's not my combination. Then 2 and 2, that's going to get me to 0 or to 4. So that is not going to work. It doesn't factor. So that doesn't mean that we can't solve this. In fact, our previous 2 sections worked on solving these types of equations without factoring necessary. So for you can complete the square, which is an option for all of you. If you like completing the square and you feel like you're good at it, feel free to complete the square. In my experience, most people have wanted to do the quadratic formula. So by all means, use that. That is personally what I would probably do. So I'm going to go ahead and do that here. If I want to solve this equation, it's already set equal to 0. I have an a value of 1, a b value of 1, and a c value of 4. So that means I need to go x is equal to the opposite of b, negative 1, plus or minus the square root of b squared, 1 squared, minus 4 times 1 times 4, 4 times a times c. And that is all being divided by 2a. Now, folks, I understand that I may not be going as slow as I normally would in a problem like this, but that's because I'm expecting that the quadratic formula is figured out from you all. And if it's not, you need to go back to that video and rewatch it. Okay, so then here I have x is equal to negative 1 plus or minus, well, let's figure out what that is. 1 squared minus 4 times 1 times 4. It's negative 15. All right, what does that mean for us? That's all divided by 2. So that means x is equal to, well, does 15, the square root of negative 15 simplify? I believe it does. I believe it simplifies into negative 1 plus or minus I square roots of 15 over 2. Now, what does this mean? What does this mean? This means that our problem doesn't cross at all. This line is not going to cross this parabola, which is why we're getting complex solutions to this equation. So what I need to see if this happens to you is, first off, I need to see this is going to be your only answer. I'm not going to require you to solve for y, although I'm going to show you how you can here in a moment. But this is kind of just the problem as it is itself, okay? So what does this mean? This means I have 2 complex solutions. Now, if you were very dedicated to actually finding the y value, you can find the y value, but it is going to require a little bit of work. So feel free to skip over this part if you want, but you can find the complex solutions if you wanted to. Okay, and so here our first solution would be negative 1 plus I square roots of 15 over 2. Minus 10. Okay, and then if we wanted to do that here, we would say y. Well, we'd have to multiply this in, so that would be negative 3 plus 3i square roots of 15 over 2 minus 10. I would need to get this as a denominator with, or have a numerator and a denominator of 2. So we would have y is equal to, I'm going to split this up into negative 3 over 2 plus 3i square roots of 15 over 2 minus 20 over 2. So negative 3 over 2 minus 20 over 2, those combine. And this would be y is equal to negative 23 over 2 plus 3i square roots of 15 over 2, which means our y value is negative 23 plus 3i square roots of 2 or square roots of 15 all over 2. Now, so this is just like so if you're getting a complex x variable, you're going to get a complex y variable as well. So that's the x and y coordinate. You'd have to do the same thing for negative 1 minus I square roots of 15 over 2. But again, I'm not requiring that. So once you're getting two complex solutions, go ahead and just give me the x variable or the x values and tell me that it's two complex solutions. Okay, let's go ahead and do the next one. We know that what y is equal to, so we're going to replace it. Okay, negative 1/2 x squared plus 2. We can minus 4 and minus x. To get 0 is equal to negative 1/2 x squared minus x minus 2. You know, personally, I would probably multiply this all by negative 2 so you have a positive a value. You always want a positive a value, so let's go ahead and do that. We're going to multiply by negative 2, so that's 0 is equal to x squared plus 2x plus 4. And then again, we're getting a problem. We're not going to find numbers that multiply to 4 and add to 2. So that tells me that we're going to have to use a quadratic formula to go ahead and solve this. So my a value here is 1, my b value here is 2, and my c value here is 4. So that means x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Alright, so this is being negative 2 plus or minus the square root of, so 2 squared minus 4 times a times c. And my calculator's off. Perfect. 2 squared minus 4 times a times c, negative 12, all divided by 2. So that means x is equal to, square root of negative 12 is going to simplify into 2i square roots of 3 over 2. These are all divisible by 2, so I would like that simplified. X is equal to negative 1 plus or minus I square roots of 3. Okay, and then again, here we got I. This is two complex solutions. Okay. All right, folks. 2 more examples for this chapter, and then we can call that wrap. So I'm going to let you all pause the video and try G and F on your own. When you are done, check it with me, and let's go ahead and do that now. We know what y is equal to, so we replace it. 3x squared minus 6x minus 5 is equal to negative 2x minus 8. And I can go ahead and add 2x and add 8. So I'm going to get 3x squared minus 4x minus 3 plus 3. Okay, so then here what we would do is we could go ahead and set the Xbox method up. I'm going to set it up over here because it ended up not working. We'd be looking for numbers that multiply to 9 and add to negative 4. As you can tell here, our combinations are 9 and 1, which will not get me to negative 4, and 3 and 3, which will also not get me to 4. So I'm going to have to use the quadratic formula. X is equal to the opposite of b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. All right, negative 4 squared minus 4 times 3 is negative 20. So 4 plus or minus the square root of negative 20 divided by 6, which means x is equal to, this would simplify into 2I square roots of 5. All divided by 6. And then these are all even, so that means they're all divisible by 2. So we're going to go ahead and do that to get x is equal to 2I plus or minus I square roots of 5, all divided by 3. And again, I'm having two complex solutions. Okay, last one. We know what y is equal to, so we're going to replace y. So here I get negative x plus 5 is equal to negative 1/2 x squared plus 2x minus 1. And I can add x and subtract 5 from each side. To get 0 is equal to negative 1/2 x squared plus 3x minus 6. I really do not want a negative coefficient, and I don't want a fractional one either. So I'm going to get rid of that negative and that fraction by multiplying by negative 2. That should get me to 0 is equal to x squared minus 6x plus 12. So that means, what does that mean? That means that I would need numbers that multiply to 12 and add to negative 6. So 12 and 1, no. 6 and 2, no. 4 and 3, no. And then I'm back to 2 and 6. So this doesn't factor. So that means I'm going to have to find my A value, my B value, and my C value, which tells me x is equal to the opposite of b plus or minus the square root of b squared, minus 4 times A times C, all divided by 2 times A. So we need to figure out what that discriminant is. Minus 4 times 1 times 12. That's negative 12. So 6 plus or minus the square root of negative 12 over 2. Square root of negative 12 can be simplified to x is equal to 6 plus or minus 2I square roots of 3 over 2. And that does simplify because these each are divisible by 2. So this is going to be x is equal to 3 plus or minus I square roots of 3. And again, I have I in my answer. This means I'm having complex solutions. Okay. That's the chapter, folks. So what I would suggest to you is go on and do the 4.7 homework. And then after that, you can move on to the chapter review. Otherwise, I will see you all next time.